Welcome back to the classroom. Today's topic is the function and application of step-down switching regulator LM2575. This video is sponsored by BuyMote shopping app. BuyMote e-shopping application is one of the online shopping app. The LM2575 series of regulators are integrated circuits that are perfect for easily designing a step-down switching regulator. These regulators can handle a load of 1 ampere and have excellent regulation of both input voltage and load. They come in fixed output voltages of 3.3 volt, 5 volt, 12 volt, 15 volt and an adjustable version. The design of these regulators aims to minimize the need for external components, making it simpler. There are also specific inductors available for use with the LM2575 from various manufacturers. Compared to traditional linear regulators, the LM2575 has a much higher efficiency, especially with higher input voltages. In many cases, the LM2575 generates such low power that it doesn't require a heatsink or can use a much smaller one. The LM2575 has several features, including a guaranteed plus or minus 4% tolerance on output voltage, plus or minus 10% on oscillator frequency, and an external shutdown option with low standby current. It also includes current limiting and thermal shutdown for protection in case of faults. Features of LM2575. The text describes different versions of a device that can produce different output voltages, including an adjustable version. The adjustable version can produce output voltage ranging from 1.23 volt to 37 volt with a maximum deviation of 4% under various conditions. It can provide a maximum output current of 1 ampere. The device has a wide input voltage range of 4.75 volt to 40 volt and requires only for external components to operate. It has a fixed frequency internal oscillator of 52 kHz and can be shut down using TTL signals entering a low power standby mode. The device is highly efficient and can use standard inductors easily available in the market. It also has thermal shutdown and current limit protection features. The device can be used in various applications such as step-down regulators, pre-regulators for linear regulators, and on-card switching regulators, positive-negative converters, negative step-up converters, and power supplies for battery chargers. The rapid switching currents caused by the wiring inductance, stray capacitance, and plastic inductance of the circuit board traces can create voltage transients. These transients can lead to electromagnetic interference and impact the desired operation. To minimize inductance and ground loops, it is recommended to keep the length of these leads indicated by heavy lines as short as possible. Single point grounding or ground plane construction should be used for optimal results. Additionally, the area of the PCB connected to pin number 2 of the LM2575 should be minimized to reduce coupling to sensitive circuitry. The feedback section of the circuit is also sensitive and it is important to keep the feedback wiring short. To ensure this, it is advised to physically place the programming resistors near the regulator when using the adjustable version of the LM2575 regulator. The LM2575 is a basic forward mode converter known as a buck or step-down converter. The operation of this regulator has two distinct time periods. The first period occurs when the series of switch is turned on and the input voltage is connected to the capacitor at pin number 1. The output voltage is determined by the inductor and the rectifier is reverse biased. During this period, the inductor current increases linearly as there is a constant voltage source across it. Typical performance characteristics of LM2575. The image shows normalized output voltage versus junction temperature. Figure 3 shows output voltage changes versus input voltage. Figure 4 shows saturation voltage versus switching current. Figure 5 shows output current versus junction temperature in centigrade. Figure 6 shows input-output differential versus junction temperature. Figure 7 shows quiescent current versus input voltage in volt. Figure 8 shows standby quiescent current in milliampere versus input voltage in volts. Figure 9 shows standby quiescent current in milliampere versus junction temperature in centigrade. Figure 10 shows normalized frequency versus junction temperature in centigrade. Figure 11 shows feedback pin current in milliampere versus junction temperature in centigrade. The oscilloscope spectrum shows output voltage of 0 to 10 volt, output current of 0 to 1 ampere, inductor current of 0.5 to 1 ampere, and output ripple voltage of 20 millivolt per division. This is the switching waveform of the LM2575. The oscilloscope figure number 13 shows the spectrum of low transient response. Pin function description of LM2575. Pin number 1 is the positive input supply for the LM2575 step-down switching regulator. In order to minimize voltage transients and to supply the switching currents needs by the regulator, a suitable input bypass capacitor must be present. Pin number 2 is the emitter of the internal switch. The saturation voltage of this output switch is typically 1 volt. It should be kept in mind that the PCB area connected to this pin should be kept to a minimum in order to minimize coupling to sensitive circuitry. Pin number 3 is the circuit ground pin. Pin number 4 senses regulated output voltage to complete the feedback loop. The signal is divided by the internal resistor divider network R2, R1 and applied to the non-inverting input of the internal error amplifier. In the adjustable version of the LM2575 switching regulator, this pin is the direct input of the error amplifier and the resistor network R2, R1 is connected externally to low programming of the output voltage. Pin number 5 allows the switching regulator circuit to be shut down using logic level signals, thus dropping the total input supply current to approximately 80 milliampere. The input threshold voltage is typically 1.4 volt. Applying a voltage above this value shuts the regulation off. If the voltage applied to this pin is lower than 1.4 volt or if this pin is connected to ground, the regulator will be in the on condition. This is the entire tutorial of regulator IC LM2575. Thank you for watching.